Now let's solve ETA past papers one by one. Now MCQs number first is, in what way do the atoms of isotopes C612, C613 and C614s are different? So option A is different charges, different number of electrons, different number of neutrons and different number of electrons. So if we observe, the given is 3 isotopes of carbon. Now we know that from the carbon they have same atomic number but different mass number. So we know that it is just examples are isotopes. So isotopes of the element have same atomic number but different mass number, or we can say that they have same number of protons and different number of neutrons. So this is definition of just isotopes. In the given are example of isotopes. So they have different number of neutrons. So the 6 shows the number of proton and the 13 shows the number of proton plus neutron. So 12 minus 6 we give us 6. In this case there is 6 neutron, in this case there are 7, and 14 minus 6 is equal to 8. So in this case there is 8 neutron. So option D is correct. They have different number of neutrons. The next is, how many nucleons are there in atom of uranium-92-235? So protons and neutrons are collectively called nucleons. So nucleons, we know that nucleons is equal to proton plus neutron. So in this case proton plus neutron is represented by the number 235, which is mass number. So mass number of an atom is the number of nucleons. So in this case 235 is correct option, that is option B. The next is, the sum of number of protons and neutrons are present in the nucleus is known as what? Charge number, mass number, atomic number and magic number. So mass number is the number of proton and neutron, while atomic number is number of what? Protons only. So this was the definition of atomic number and mass number, simple MCQs. The next is, the atoms of an element having same atomic number, different mass numbers are called isotopes, isotone, isomer and isopar. So according to the definition of isotope, we know that isotope have same atomic number but different mass number, or they have same number of protons and different numbers of neutrons. The next is, how is it possible to distinguish between the isotopes of uranium? The nuclei have different charge and different mass and they emit different particles when they decay. Option B, the nuclei have same charge but different mass. Option C, the nuclei have different charge but same mass. The nuclei have same charge and mass but they emit alpha particle. So from the definition of isotope, we know that isotope have same atomic number but different mass number. It means that they have same number of protons but different number of neutrons. So proton have positive charge, while neutron have no charge. Is now isomers have same number of, as isomer have same number of protons, same proton. So it means they have, so it means that they have same charge, because neutron have no charge. So the mass of isotope nucleus is due to the mass of proton, and isomer have same number of protons, so it have same number of charge, while neutrons number of different, while neutrons number are different. So is different, neurons number of different, so they have mass, so mass is different. So we can say is result isomers have same charge isomers nuclei have same charge but different masses. Same charge is due to same number of proton and different masses is due to different number of protons. So option B is correct. The next is the amount of energy required to break the nucleus into constituent nucleus is called, it is binding energy. Definition of binding energy is the binding energy is the amount of energy required to break the nucleus into constituent that are proton and neutron. So this is the definition of binding energy. Just the next is the expression for binding energy is option A, B, C, D and so on. So we know that for binding energy, this is for binding energy we know that the mass of nucleus is a whole less than the mass of protons plus mass of neutrons. If we add the mass of proton and the mass of neutrons, the S nucleus contain mass of proton and neutron, but if we measure the mass of proton and neutron separately and mass of nucleus separately, so the mass of nucleus will be less than that of the mass of proton and neutron, and this defect is called binding energy. So now we know that for binding energy, again for binding energy, writing equation, the number of proton minus mass of nucleus. So the mass of proton minus the mass of neutrons. So we know that for the mass of neutrons, so Z is mass number, so this is Z is the number of protons, and number of proton into mass of one proton will be a total mass of proton. Now Z or N is the number of neutron and Mn is the number of mass of one neutron. So Nmn is the mass of total neutrons and the mass of neutron is called Amz. So if this is the mass of mass, so this is the equation for binding energy. So this equation we see, this is for mass defect, and same as I wrote above, this is for mass defect, this is for mass defect, this is mass defect, and E is equal to mc square, so we will multiply it by mc square, or EB, that is the binding energy, is equal to mass defect multiply by c square, or E is equal to mc square. So here the mass defect is mass of proton plus mass of neutron minus mass of nucleus, or EB is equal to the into the, this is the mass defect and this is the square of the c square. So this is equation for binding energy, option B. The binding energy per nucleon is greater than lighter nuclei, heavy nuclei, intermediate nuclei, and none of these. Now binding energy per nucleon. So if this is binding energy per nucleon, this is equal to binding energy and divided by total number of nucleon. So as we can see that E is inversely proportional to is energy per nucleon is inversely proportional to the, as E is inversely proportional to the nucleons or number of nucleon. So if EB is same, binding energy is same, so the heavy nuclei which contain large number of nucleons will be less energy per nucleon. Now as in this case for lighter nuclei, if nucleon number of less, so energy per nucleon will be high. So the option A is correct. Anyway, this is old book MCQs, just skip it. Which statement correctly describes the nucleus? So any atomic number, any atomic nucleus, radioactive atomic nucleus, neutrons are a proton are an electron. So we know that nucleon is the term used for protons or neutrons that lies inside the nucleus. So we know that the nucleus contains neutrons and protons, so for those neutrons and protons we call it nucleon. The next is, in nuclear reaction uranium-238 converted into thorium Az helium, the value of A and Z are this. So as we can see, this is helium. So as we can see that alpha particle has decayed. So in the equation we can see that this is alpha particle, which is nucleus of the helium atom. So as we can see in the reaction, alpha particle is decayed. So 4 2, so the A will be decreased by 4 and Z will be decreased by 2. So in this case, as helium is found, so 92 minus 2 we will get at 90. So option 90 is correct. So option Z will be 90, and this is decreased by 4, so 38 minus 4 is equal to 234. So option C is correct. So A will be decreased by what? By 4, and Z will be decreased by 2. So this is the decay of alpha particle. Now atomic mass unit in term of energy is equal to, so we know that 1 U is equal to 931 mega electron volt. So this is the relation, you must remember it, there is no need of derivation. Now we know that 1 U, if you know that just nothing but 1 U is equal to 1 over 12 of 1 U. Also remember this, 1 U is equal to 1 over 12 of what? 1 over 12 of mass of one carbon atom. Mass of one carbon atom. Now to find the mass of one carbon atom, we will use that 1 mole is equal to Na atom. So 1 atom will, so this is lengthy calculation, but just remember that 1 AMU is equal to 931 mega electron volt, or 1.6 multiplied 10 raised to power minus 27 kg. So the rest mass energy of an electron is, so we know that E is equal to mc square. So by putting mass of electron and speed of light, we will get 0.51 joule. Answer is our answer. This is the example of second year book, no need to solve it, or just remember this value. This is for one electron. Which two nuclei contain same number of protons? So this is board option. This might be the answer, but let's check it. Now we know that this is the upper number is A and this is Z. A minus Z is equal to the number of neutrons. So in case of option A, so here NC12 are, so in this case we can see that the number of neutron is equal to 12 minus 6, so the number of neutron is equal to 6. In this case, so in this case we know that the number of neutrons is equal to 14 minus 6, which is equal to 8, which are not same. So option C is incorrect. The next is about 17 and 6. So in this case, if we see that 16 minus 7, so 16 minus 7 is equal to 9. In this case 15 minus 8 is equal to 7. So 9 and 7 are not equal. So 9 and 7 are not equal. So option B is incorrect. Next is option C, 23 minus 11. So from 23 minus 11 we will get 11. 23 minus 11, 23 minus 10 is equal to 13 and 1, 12. So in this case the number of neutrons is 12. In this case 24 minus 12, the number of neutron is also 12. So option C is correct. No need to go into the option D, because option C is correct. And for that case we know that Na is equal to 23 minus 11 is equal to 12. In the second case for Mg we know that 24 minus 12 is equal to 12. So this is correct. Now going to the for next MCQs. The next is, which one of the following will be a better shield against X-rays? So we know that X-ray can pass from ordinary water, hard water, which type of water it is, but X-rays passes from water. The next is, it can pass through lead but it can't pass through lead but aluminum. From aluminum is thin, or it can pass from aluminum but the tin are lead. So remember that the lead is given in the example. So remember the example of the books that X-rays can't pass through lead. This is given in the book. And it can penetrate means it can pass through, it can penetrate all types of water, either it is soft or hard. So the next is the nuclear equation. So is the term missing. There is something missing in the equation. This is the equation. What is represented by missing term? So anti-neutrino, an electrono, a neutrino, a positron. So as we can see in the equation, this is beta particle emission. This is beta particle emission. So neutrino and positron and electron are not correct option, but the result is neutrino and anti-neutrino. So if we can see, this is electron is being removed. This means that electron has been Control X. It means that electron has been removed. So when the decay of electron occurs, so an anti-neutrino released with an anti-neutrino. This is an anti-neutrino. An anti-neutrino is decay with electron decay. If it were a positron, then neutrino will be decayed. The next is, so option A is correct. And if this were +1, so then option C will be correct. When lead Pb8234 emits beta particle, the resultant nucleus will be what? So we can see that if it decay beta particle and that is negative beta particle, it means that an electron has been removed. So as electron is removed, as we can say that as we can see that this has decayed. So this is electron. So the positive charge as electron were removed by the body by a nucleus. So an atom when remove negative charge, so its positive charge increase by 1, or Z become Z plus 1. In this case Z is equal to 82, so it will become 83. So the only option is option A. So in this case 82 is increased by 83, while the 214 will be remain same. It will not change in the emission of beta particle. The next is, in the nuclear reaction shown below, what is the value of coefficient Y. So there is something removed. Now they have asked for D. So we know that in the given reaction uranium reactant 1 neutron. So this gives barium krypton and they have asked for this. So now we will see, now we will check a balance. Now for the check of the balance, we will see that 92 is equal to 53 plus 36. This is the number of proton. So 3 and 6, 6, 7, 8, 9, 9 and 3 and 5, 8. So from the balance we can see that the number of total protons. So on left side, number of protons are 92. So right side must also have same protons. So as the number of proton left side is 92, so right side must also have 92 protons. So as we can see that his number of 53 plus 36. So 53, 59, 69, 79, 89. So is number of 89 and this is 92. So 89, 90, 91, 90, 91, 92, 93. So 3 protons are missed. So the number missing is 3. So if we put 3, if we put this 3 here, then the number of proton on both side will be same. So the correct option is option. So the correct option is option D. Now going to next MCQs. So by putting 3 we get our result, which is 53 plus 36 plus 3 is equal to 92. That was enough. And next is, which equation represent a B negative decay? So Newton made proton, positron and antineutrino. Neutron from proton, positron, neutrino. Proton from neutron and positron and antineutrino. Neutron, positron and neutrino. So we know that proton always decay into neutron and positron. And next time is with positron also, whenever the positron is produced, neutrino will be formed with it. So in case if this were electron, then it will be anti-neutrino. So anti-neutrino with is electron is our fast MCQs like in this case. So going back, so where was that? That was, so looking at for it, searching for it again. So here it was, a nuclear equation is term missing. So which one it is missing? Is in this case electron has been removed, so electron get an anti-neutrino. If it is positron, then there will be neutrino. So in this equation there is neutron plus positron, so positron there will be neutron will be produced. So the answer is proton forms neutron forms one proton and form positron and neutron, and what neutrino is formed with positron. So option D is correct. And next is isotope which decay beta emission to produce CD11148 is. So beta negative mean its atomic mass will be increased by 1. So the isotopes which decay by the emission to produce the, so is it formed from something? Candela is formed from something. So these 4 elements, one have formed candela. So is one form another atom and it has been emitted B negative mean electron. So if electron is removed, the number increased by 1. So this number is already increased by 1. It was 47. So in this case it is 47, it is 47, it is 47. So option A, B, C and A, B, C 1 is correct. Now To decay beta particle, this mass number remain constant. It doesn't change. So it will be a 111. So option A is correct. So the solution is emission of beta particle increase the atomic number by 1, while mass number remains unchanged. So the mass number remain unchanged while the atomic number is increased by 1, like in this case. So this was the answer. Is Ag 111 remain constant, but 47 will become 48 because negative or electron has been decayed with it. So the next one is, an atom has a net charge of -1. It has 11 electrons, 20 neutrons. Its mass number is what? This is little tricky, but it's also so easy. We know that mass number is equal to number of protons and neutrons. So in this case is 20, and what is proton? Number of electron is also always equal to the number of proton. So in this case 18 electrons, so there will 18 protons. So 20 plus 18 neutron, which is equal to 38, is the mass number. 38 is the mass number, but in the question they tell us that an atom has net charge of -1. It means that minus charge is an electron, that it has gained 1 electron. So when an atom gain 1 electron, its positive charge will be decreased by 1. So as 1 electron is lost, so mass number will decrease by 1. Decrease by 1 because when an atom gain electron, mass number, proton number decreases. So it will be 38 minus 1, that is option is 37, that is option C is correct. Now the next MCQs is, which one of the following has same number of electron is in alpha particle? So this is option B is hydrogen, option 4th is water, and option A is hydrogen. So remove option A, B, C from the choices, because an alpha particle is what? Alpha particle is just like helium nucleus, only containing 2 protons and 2 neutrons. So alpha particle have no electron. So alpha particle has alpha particle have no electron. In this case hydrogen is H plus. H plus mean H positive mean, so option C, H positive means it is last electron. So as it last electron, so no more electron is present in it. So alpha particle have also no electrons. So H plus also contain no electrons. So both have same number of electron. Same number of electron means both have 0 number of electrons. Gamma rays have high penetrating power than alpha and beta due to no charge, no material nature, small size, lighter particle. So the option is A, D is wrong, option A is correct. Gamma rays have no charge. No, option D is correct. Gamma rays have no charge, it is right, but it is high penetrating power due to high speed, and they also have high energy. This is photons. Gamma rays are actually photons, so they have high energy, so they have high penetrating power. The next is, when alpha particle is emitted by radium-226-88, the daughter nucleus is radon mass number and charge number of which will be what? So if we know that when alpha particle is removed, the atomic number is decreased by 2 while the mass number is decreased by 4. So if we decrease the number by, this mass number will be decreased by 2. So is it 88? So it will become 2, and 226 will be decreased by 4 and 226 will become 222. In this case random, so check the option now. So this matched it, 222 and 82 matched it, option B. So option B is correct. Now we can also say that alpha particle decay results. What it results at alpha particle result A minus 4 and Z minus 2. So this is alpha particle result, that A is decreased by Z and Z is decreased by 2. A particle was ejected from the nucleus of an atom in radioactive decay and atomic number of atom is increased. So as the atomic number of atom is increased, the particle was probably a beta particle. So in beta particle, when negative or electron is decayed, in beta particle there are two possibilities, electron and positron. So in beta particle, when electron is decayed or removed, it results increase. It results increase in what? It results increase in atomic number, while positron decay results decrease in atomic number. So these are the 2 points of beta decay. When beta particle is emitted from lead, the mass number and charge number form is. So this is, we see that the beta particle negative is emitted. So as negative charge is emitted, so positive will increase by 1, or as negative charge is removed, mean electron is removed. When electron is removed, the positive charge increase by 1. So the positive charge is increased, the positive charge means proton is increased. As proton is increased, so 82 will become 83. So option C is correct. So emission of beta negative particle increase the atomic number of 1, and emission of, and also remember that emission of beta plus 1 particle decrease decrease the atomic number by 1. In the nuclear reaction, the particle X is, so what is, we can see that this 11 is increased by 1. So again the answer is same. It is emission of beta negative particle which atomic number is increased by 1. So this is option A. The next is a zinc chromium nucleus is a B negative. Again the product of nucleus is also B nuclear emitter. What is the final resulting of these two decays? So is the emission, they have not given us the atom, so it is little bit difficult, but in the coming ETA or updated ETA they always give it. So someone made mistake in composing that. So the option is simply, the trick is they have decayed the beta particle 2 times. So as the beta particle are emitted 2 times, so the number of proton will be increased by 2 times, so it will become double. So the option B is in this claim. Or zinc chromium, this was in the given option, it was 40, so it is increased by 2. When lead P beta emits beta particle, then resultant nucleus is, again this is same question, 81 will become 82 and the 214 will remain same. So option A is correct. So this is the same question repeated again and again by every ETA. So in this case this is also the answer. Now radium, when disintegrates into the cause the emission of what? So as we can see that 48 is decreased by 2 and 226 is decreased by 222. So decrease of 4 in A and 2 is can be seen in Z. So the A change in A is 226 minus 222, that is 4, and for Z the change is 48 minus 46, that is equal to 2. So when A is equal to Z, so for alpha particle A is equal to 4 and Z is equal to 2. So the emission of alpha particle has taken place. The next is the following reaction might be used for controlled fusion reaction. The following reaction might be used to control the nuclear fission reaction. This is the reaction. What is the particle X? So we can see that the number of proton is 3 and 1 4. So in this case the number of protons are also 4 and the number of neutrons is 7 minus 3. 7 minus 3 is equal to 4. 2 minus 1 is equal to 1. So the number of neutrons on left side are 7 minus 3 is equal to 4. 2 into 2 minus 1 is equal to 1. So 4 plus 1, 5 neutrons are in left side. So on right side the number of neutron is 4 minus 2 into 2 and 2 times helium. So 4 neutrons are on right side. So it has option C is correct. It has, so X is neutron. So for any reaction the number of electron proton must always be same. So the option C is correct. Again we can see that here this is 3, the number of proton, this is 1, so the number of proton is 4. In this case helium proton is 2 but it is multiplied by 2, so the number of proton is 4. Again the number of proton on both sides are 4 and 4. Now for the number of neutrons, so 7 minus 3, A minus it is the number of neutrons, so the number of neutrons in this case 7 minus 3 is equal to 4. In this case 2 minus 1, the number of neutrons is equal to 1. Now in this case the number of neutrons is equal to 4 minus 2 is equal to 2. Now multiplying it by 2 because there are 2 helium nucleus, so multiplying it by 2, 2 plus 2 is equal to 4. On this side we have 4 plus 1, that are 5 neutrons, but in this case we have 4 neutrons, so the X must also have neutrons. So if this is 1 neutron, so 4 plus 1 will then is equal to 5. So 5 plus 5 is equal to 5. So X must have neutrons. So this was the option C is the correct answer. The next is the path of beta particle in air is erratic, straight, circular. As we can see the beta particle move in a straight line, but due to collision the beta particle is erratic. So the path of traced by alpha particle is straight, while by beta particle it is erratic. And next is which one following his same number of electron is in alpha particle. This is again this question that is repeated by each helium plus, because alpha particle have no electron, because H plus like alpha particle have no electron. This is the no need to write any other option or no need for any more explanation. The next is a radium atom, radium 226, Z is equal to 86, emits an alpha particle. The number of proton in the resultant atom is. So we know that from alpha particle the Z decreased by 2, A decreased by 4 and Z is decreased by 4. So 226 will become 222 and 86 will become 82. Now is the question they have given that is now is in the question they have given that is given alpha particle is removed. This is alpha particle, so A will be decreased by 4 and Z will be decreased by 2. So in this case radium will become what? It will become the Z, that is 226 will be decreased by 4. So 226 minus 4. So 226 minus 4 is equal to 222, and the Z, that is mass number, will be decreased by 2. 86 will become 84. Now this is the resultant. Now number of neutrons is equal to number of neutrons is equal to A minus Z, are always minus the small number from large. So 222 minus 84 is equal to 80. So now they have not asked for number of neutrons, they have asked for the number of protons. So the number of neutron is 84. 84 shows us the number of neutrons. So here the option A is correct. The next MCQs number 971. A nucleus with mass number A and atomic number Z undergo beta decay. The mass number and atomic number respectively of the daughter nucleus is. So we can see in beta decay. In beta decay, the first point is no change occurs in atomic number. So the atomic number that is represented by A, no change will occur in A. So option A is correct, option D is pass. Option A and option D for atomic number is correct. Now the daughter nucleus, so the beta particle have two types of decay, either beta negative will be decayed or beta positive. So in this case, if beta negative is decayed, so option Z plus 1 is correct. That was composing mistake. So option this is correct. So this was the same MCQs like in beta decay, emission of beta negative cause increase in atomic number. So this is the answer. Next are MCQs of radioactive substances. So let's start it. In the radioactive substances has a half-life of 60 minutes. Due to 3 hours, the percentage of material that decay is. So we know that in question they first write half-life. Half-life is 60 minutes. Now the given time is, they have given is 3 hours. 3 hours mean 180 minutes. 3 hours is equal to 3 multiplied by 60 minutes. It means that 3 times half-life will take place. The time is enough for 3 half-life. So the substance will decay 3 times. So the question is asked the percentage of decay material that decay would be. So how much decay would be occur? So if we have 100% substance, so option first decay, it will become 50. It will be 50% will be decayed and 50% will be left. Out of 50% left after the first decay, after this was the, I will write it first decay. Now in second decay, 50% substance that is already removed will be 20% will be decay and 20% left. Now for third decay, out of 20% remaining, 12.5% will be remain and 12.5% the rest will be remained. So after third decay, the resultant is, this is the left substance. This is the what? This is the left over. While decayed, it was 100%. Now the left is 12.5%. So the decayed amount is total amount at the start minus left over. So here it was 100% at the start and now it is 12.5. It means that the rest has been decayed. So the rest has been decayed is 87.5%. If they ask the same MCQs but they say that the percent of material that left is, then the option will be 12.5%. Now the activity of certain nuclide is governed by the relation the where 2.4 multiplied 10 to the power minus 6 second, where what? This is I think lambda. What is the half-life of nuclei? So this is given as where lambda is equal to this. So we know that lambda into half life is equal to 0.693 or 673. I am little confused in that. So lambda is equal to 0.693. So this is given as lambda. So from this equation, putting lambda, we will find t. So just solve it, and option A will be according to them correct. No need to solve. Two radioactive sample S1 SO2 have half life of 3 hours. So two have sample S1 and 2 half life is 3 hours. Next, and 7 hours. So the first one is the first one have half life of 3 and the second half life of 7 hours. If they have same activity at certain instant t, what is the ratio of number of atom of S2 and S2 at any? If they have same activity at certain instant t, so what is the ratio of number of atom of S1 and S2? So let's skip it. We will do it in next tutorial. A radioactive isotope is 3 type, which is reduced 6.5%, or maybe this is quite easy, so we can do it in just 5 seconds. Like radioactive isotope is half life of 3 days, the time after which it decays to reduce it to 6.25%. So it's easy. If present substance is 100%, so after first decay it will become 50, and next decay it will become 25. So in next decay the remaining substance will be 12.5. After that the substance will be 6.25. So how much decay did occur? 1, 2, 3, 4. 4 times decays is occur. One decay occur in 3 days. So 4 multiplied by 3 is equal to 12 days. So it has taken as 12 days. A medical lab is 16 gram of sample of radioactive isotope. This is 2018 MCQs that a medical lab is 16 gram of single of radioactive isotopes. After 6 hours, it was found that bar gram of sample has decayed. The half-life of isotope is. So they given us that lab was 16 gram of isotope. So after 6 hours, it was found 12 gram of sample have decayed. No. Now if this was 60 gram of MCQs, so after first decay the left substance will be 8 gram. So after first decay the left substance is 8. Now after second decay the left substance is 4. So the leftover substance is after second decay is 4, while the decayed substance is, the sum is 16, so 16 minus 4, 16 minus 4 is equal to 12. So 12 gram is decayed, so it means 2 time lifetime has passed. So the lifetime is 6 hours, so 12 hours is fast. So the option A is correct. Is 2 decay occur or after 2 decays? After 2 half lives, leftover is 4 gram, while decayed substance is decayed substance is 12 gram. The next is a source containing initial inert nuclei of radioactive nuclei. How many the nuclei have decayed at a time interval of 3 half lives? So if this is inert, so the given substance is inert, so we can say that if this is inert was original substance, so after first decay it will be decreased by 2. Now next, after second decay this inert by 2 will be also decreased to half. So this inert by 2 will be decreased by 2. They have asked interval of 3 half lives. So after we can also write this is inert by 2 2s are 4. Now after this was first decay, this was little explanation for you. So this was first decay, the inert becomes half, and second decay, the resultant of first decay will be again reduced to half. So n naught by 2 divided by 2 is equal to n naught by 4. So now in third decay, the resultant of second decay, that is n naught by 4. So n naught by 4 will be decreased by 2. So 2 4s are 8. So this will be n naught by 2 4s are 8. So this is the leftover substance after third decay. So the question is, how many of these nuclei have decayed? How much decayed? So n naught by 7, n naught by 8. So total, how much was total? Total was n naught. So total was n naught. So on, and now leftover, in this case we have found that after 3 times leftover is n net by this. So decayed have, how much is decayed? So we know that after some time some of the substance decayed while some is left over. So in this case leftover plus decay is also is equal to n naught. So in this case, if n naught is equal to n naught by 8, it means 1 over 8 is being left over, while 7 by 8 is 7 by 8 n naught is decayed. 7 by 8 n naught or 7 n naught by 8 has been decayed. So option D is correct. So the half-life of radioactive source is 2.3 days. A decay constant per day will be. So a decay constant per day will be. The half-life of radioactive substance is 2. So now we know that lambda T into half-life, T into half-life 1 by 2 is equal to 0.693. Now in this case they have given us lambda. So lambda is equal to 0.69 by lambda. Now in this case they have given us time. So we will get that lambda is equal to 0.69 by T. So 0.69 here days is equal to 2.3. They have asked in days. So if they ask constant per day, if they ask that this is point constant for option 0.3 is correct. But if they ask second instead of days, so then we will convert 2.3 days into second, multiplying by 24 hours, and each hour we will multiply by 3600. The next is a half-life of NADA is 2.6 years. If X gram of this sodium isotope of initially present, initially substance was X, how much is left year after 13 years? So how much decays occur? First we will divide 13 by 2.6, so we can get our decay. So 13 divided by 2.6 mean 13 divided by 2.6 means 2 4s are 6 4s are 12. So 4 half-life and 4 decays occur. So from the given time 13 years is enough for 4 half-life. So after 2.6 then it will become 5.2, this and so on. 13 years 4 decay will be occur. So the substance present is, so we will do, this is lengthy way, so we will do it by easy way. Like we will say that in first decay, like second decay occur. Now when third decay occur, the total decay will occur will be 4 decay. So 4 decay will occur. So in first decay, the amount of substance that is X present, it will be divided by 2. Now in the next, the X by 2 in turn will be divided by 2. So it will become the X by 2 will becomes x by 2 will be divided by x by 2 divided by 2, or x 2 2s are 4, x by 4. Now in third decay, that, so this was x not w. So now in the third decay, the x by 4 will be divided by 2 again, so it will become x by 8, and so on. And next, x by 8 will be again divided by 2, so it will become, so x by 8 will become x by 8 by 2, so x by 8 by 2 is equal to x by 16, x by 16. So observe, so if x gram of sodium isotope of initially present, how much is it left over at 13 years? There was little mistake. 13.6 is equal to 5. It means 5 time decay take place. So fifth decay, so fifth time decay will occur. So at fifth decay, x by 16 will be again divided by 2, so x by 16, it is divided by 2, is equal to x by 14. So this is the, not 14, this is x by 16 divided by 2 is equal to x by 32. So x by 32 is the leftover substances, while 31 divided by 32 has been decayed. So this is x by 32 is decayed substance. So this option A is present. So the present substances was x. So after 13 years, the leftover substances is x by 32. And decayed, how much is decayed? If they ask in decay and coming eta or any other test, and decayed substance is how much? 31 by 32. So this was about. So we will solve the next MCQs, and in the next section it's enough for today.